Hey, so this is probably a major weird accomplishment, but I have sitting in front of me the strangest thing I have ever seen. I mean, on the surface, this is pretty straightforward. It's a TS100 by WF, let's just call that Springfield. We don't know what state it's from. We really don't know anything about it, in fact, but let's continue. It's got this interesting little clock face on it, and I'm kind of keeping the angle low as to not give away the secrets, because boy, there are secrets. But you would wonder what's going on in this thing. It has settings for AC and DC power, I'm guessing, and then an oven switch, which, I don't know, you would suspect maybe it's for controlling the temperature or timing of an industrial process, but boy, it gets weirder. So you turn this on, and this really cool little clock after a moment starts running. It has a mechanism to let you immediately zero out the sweep second hand, and this is moving slowly because it really needs a cleaning and lubrication. Like, yeah, there it goes. I think that delay is not intentional. It's probably just that the motor's grease is all, well, yeah, it has changed from oil to primordial ooze. Yeah, the usual preservation issues. That has a dial to set the hands here, and you can hear some little clicks happening when I do that. Well, let's go into the clock mechanism first, and boy, that is a clock. So what we've got going on in here, I think, and it appears to have stalled due to grease issues. No, it's still running, okay. Oh, I was looking at the reset gear, not the drive gear back here. But along with that drive gear, 2 cams are running, and it looks like they'll reach the leaf switches in a moment. These trigger once per minute as it's running. Come on, give me the click. Oh, the waiting game. There it went. And this other set of cams are connected to the minute hand and trigger once an hour the same way. I am not really sure what the function of these cam switches is, because I think all they do is go to this terminal strip on the back, but then it gets even weirder. So you saw that oven switch before. I think what's going on in here is, although it's cold to the touch right now, that doesn't necessarily mean anything because this box is probably packed with insulation, but I think there is an oven-controlled oscillator in here. There's a calibration hole through the side, which, if you slide this into place, is accessible. This was probably glued down with some tape or something that has ceased to be. But then there's all this stuff over here, and I think what this actually is a precision 60 hertz power inverter. Because on the back, there's a socket which says it's good for 7 watts. 7 mighty watts out of what are probably these germanium power transistors here. Sometimes you can just tell from the age, because nobody gold plates these devices unless they're made for like super high reliability use. There's a capacitor which has not popped, 2 transformers, and I have the suspicion that this precision oscillator over here is actually what's powering this clock. So it runs at a precise, internally regulated 60 hertz, and this whole thing is a 60 hertz reference and timing unit of some sort. Now, what this was used for, I have no clue. There is no history accompanying it. I just found it at the surplus place, and it looked interesting. I thought this clock mechanism looked neat, but I was not expecting any of the stuff inside. I want to hook up an oscilloscope to this and see exactly what it's putting out. Through the looking glass, we have 60 hertz. Seems pretty close. It's off by a tiny bit. It actually was at 60.0 before it started warming up a little bit, which suggests to me a slight calibration adjustment may be needed. I don't really know how precise this unit was actually supposed to be, but I also kind of suspect that this clock is your way of testing it. You would check this against, well, ideally, pull up your shortwave receiver, check against WWV, let it run for several hours, make sure it's still right on target. The waveform is, I mean, great. Certainly good enough to use as a reference for 60 hertz power. And let me see here if there is a way I can tell it to show me the voltage on here. Right. Measure. Awkward little menu. I don't use this scope very often, sorry. Right. Add measurement. Let's add RMS. And, well, it didn't appear. Oh, okay, here we go. Add measurement. Okay, we have 102 RMS, which, I mean, that seems perfectly fine for such a weird waveform. Peak to peak, I'll add that to the measurement box too, and apparently knock the measurement box right off the screen. Cool. This is a really nice scope, but I am still getting used to the idea of touch screens on scopes. How did I get back? Okay, here we go. Add peak to peak. Wait, add it. Oh yeah, this is nasty. I've actually seen another power square kind of modified sine wave power inverter do this in the past, and it's these nasty peaks that are driving up the measurement. That particular power inverter was pretty amusing. It came back to me for service at a place I used to work with the customer's complaint being that their bathroom exhaust fan exploded. Well then, the fart fan probably shouldn't fart fire, you know, but I guess just watch out with this thing's output because it's a little spicy. But yeah, I want to do a little more on this thing, especially exploring what's inside that time base unit, but I was just so excited, like, what the heck is this thing, that I just had to do this for now. I hope you enjoy this very strange exploration of this very institutional green device.